Math 3, Practice 2B.2.2, Solving Radical Equations. So, problems 1 through 3, we've got a radical equation we're solving for x. So the idea is that you need to get the radical by itself, like 1 and 2 already have it set up, 3 not so much. And we are getting them by themselves, and then we can undo them by the powers. So, the first step we want to do is we want to square both sides. We square both sides because squaring a square root undoes it. So we get x minus 3 on the left side equals 6 squared is 36. So add 3 to both sides, and you get x equals 39. Okay. Then typically what you need to do is plug the numbers back in, because sometimes some won't work. Like this one, 39 minus 3 is 36. Square root of 36 is going to give us a positive or a negative 6. Okay. Which the positive 6 works. Alright, second one, same idea, right? Square these. Those cancel, we get x plus 6 equals x squared. Now, here's the problem. How are we going to get rid of that squared? You could say take the square root, but that takes us back to where we are. So, what you have to do is get these on the same side and turn this into a quadratic, basically. Okay. Then we can solve for the quadratic using the quadratic formula, graphing it, using polynomial tools on the calculator, or using the area model and saying, okay, negative 6 is 3 times 2. Well, if 3 is negative, that's a negative 6, and I add those, that's a negative 1. So we'd end up with x minus 3 times x plus 2. Then each one separately, we'd set equal to 0. So we'd get x equals 3 and x equals negative 2. Okay, then we can plug them back in to see which ones work. So 3 plus 6 equals 3. 3 plus 6 is 9. Square root of 9 is a positive or a negative 3. So yeah, gives us a positive 3. That one works. So we know 3 is a solution. Then we try it with 2, negative 2. Negative 2 plus 6 equals negative 2. Negative 2 plus 6 is 4. Square root of 4 equals negative 2. Square root of 4 is positive or negative 2. So technically that one will work. Because when you square root something, you could have the positive or the negative version of it. So yeah, that one would work as well. Okay, now the last one we have to do some work. So first we'd subtract by 5 to get 4 cube roots of x plus 1 equals 1 minus 5 is negative 4. Then we divide by 4. And we get the cube root of x plus 1 equals negative 1. Then we cube everything instead of squaring it. That undoes the cube root. We get x plus 1 equals negative 1. Subtract 1, and we get x equals negative 2. Okay, number 4. A rectangular window is twice as wide as it is long. The area enclosed by the window is numerically equivalent to the length of the shortest side of the window. Find the area of the window. So we've got this window. It says it's twice as wide as it is long. So this would be 2x if this is x. It says the area enclosed by the window is numerically equivalent to the length of the shortest side of the window. Okay, so the area here is the same as that shorter side. So essentially what we have going on here is the area would be length times width would be 2x times x, okay, is going to be equal to x. So I get 2x squared equals x. So we've got this problem here. Now, notice we have an x and an x on this side. So I can divide by an x. Okay, that'll give me just 2x equals 1. Divide by 2, and I get x equals 1/2. So the area would be 1/2 units squared, or square units. Okay? That's kind of a weird one, huh? Let's try number 5. Number 5, we've got a right triangle, has a hypotenuse measuring 17 inches long. If one leg measures 8 inches, what is the length of the other leg? Okay, well this we can use a Pythagorean theorem, right? A squared plus b squared equals c squared. So c is 17. One of the legs we'll call a squared, the other one is 8. So I get a squared plus 64 equals 289. Subtract 64, and we get a squared equals 225. Take the square root of that, and I believe that's 15. So the other leg would be 15. Alright, number 6. When an object is dropped from a great height, gravity causes the object to speed up as it falls. When the object strikes the surface, the velocity at which the object was traveling at the moment of impact, ignoring air resistance, can be determined using this formula. V equals the square root of 2 times g times h, where v represents velocity, g acceleration due to gravity, and h is height of the object. On Earth, an object's acceleration due to gravity is 32 feet per second squared. From what height must a stone be dropped to reach a velocity of 128 feet per second at the moment it hits the ground? So v is 128 equals the square root of 2 times g is 32 times h. Okay, so 2 times 32 is 64, so 64h, square root of that, and 128. Okay, now there's two ways we can attack this problem. Okay, we can realize that we know what the square root of 64 is. So we could split that up to the square root of 64 times the square root of h, and then the square root of 64 would be 8. Okay, and so then we would go 128 divided by 8, and we'd get something equals the square root of h. So 128, that would go in at once. 16. That sounds about right. Then we square that, both sides, so we get h equals 16 squared, which is 256. So it would be 256 feet, would be the height. Okay, the other way we could do that would be to square at the beginning. We'll get the same result, but we'd say let's square right here, and then I'd get 128 squared equals 64h. So then whatever 128 squared is, that one I don't know offhand, oddly enough. You may find that surprising. So that would be 16,384 divided by 64 then, and we end up with the same answer. I kind of like my first way better because it was easier for me to do, but either one works. Alright, number 7. The time it takes an object to fall from a great height depends on the object's acceleration due to gravity, as well as the height from the object from which the object is dropped. So we've got another formula. H equals 1/2 g times t squared. T is time, h height, g acceleration, which is 32 feet per second squared. The cliff diver leaps from a height of 164 feet. How long will it take him to reach the water? So we're looking for time. So g is 32, t squared. So 32 times 1/2 is 16 times t squared equals 164. Divide by 16. So 164 divided by 16 is 10.25 equals t squared. So then we take the square root, and we get t equals the square root of 10.25 would be positive or negative 3.2. Can't have a negative time, so it would be 3.2 seconds, roughly. Alright, number 8. Accident investigators can estimate the speed of a vehicle involved in a crash by examining the skid marks left by the tires on the pavement. The relationship shown by this formula is right here. With S representing the speed in miles per hour and D representing the skid distance in feet, the value F is determined by the friction of the pavement. Wet concrete is much more slippery than hot asphalt. A typical value for F, assuming a dry roadway, is 0.7. After a minor car accident on a dry day, Charlie insisted to his parents that he wasn't exceeding the 35-mile-per-hour speed limit. An accident investigator found that the skid marks left were 75 feet long. So we'd go S equals the square root of 30 times 0.7 for F times 75. So basically we're just going to type this one into the calculator, right? 30 times 0.7 times 75 is 1575. Take the square root of that. And we get about 39.67 if we round. So, was he going too fast? Yes, he was. Alright, number 9, dealing with electrical circuits. The current is related to the power and resistance according to this rule. I equals square root of P divided by R, where I represents the current in amps, P, power measured in watts, and R, resistance. What is the electrical power drawn by a device that has a resistance of 15 ohms with a current of 4 amps? So I is 4, square root of, we have resistance 15, and we're looking for P, aren't we? So this one, best thing to do is to square to begin. 4 squared is 16. Squaring a square root gets rid of that. P over 15 times by 15. So 15 times 16 gives us 240 watts. Is P. Okay. So last one, number 10. For a sphere with the radius r, the volume V can be found using this formula. V equals 4/3 pi r cubed. Find the radius of a sphere with a volume of 288 pi. So our volume is 288 pi equals 4/3, and we want to find the radius, pi r cubed. Now, first thing you should notice, we have pi on either side. So when you have pi on either side, you eat them both, and we get 288 equals 4/3 r cubed. So I'm going to times by 3/4, right? We learned that in the rationals, timesing by reciprocals. So 3 is undue, 4 is undue. I'm left with r cubed equals then 3/4 times 288. 288 times 3 divided by 4 gives us 216. So to undo a cube, we take a cube root, and we get r equals the cube root of 216, which is 6. Radius is 6. Alright, so there we go, guys. Yeah, call that one good then.